What is up, athletes? So today we're going to look at the t-test. So you saw what the z-test looks like. So let's look at the difference between the z-test and the t-test. All right. So let's look at question number 3 here. And I got my calculator ready. So make sure you have yours ready. And let's dissect this. All right. So college tuition. The mean annual tuition and fees this academic year for a sample of 25 private colleges in California was 35,500 with a standard deviation of 7,600. All right, so number one, remember these numbers came from this sample of 25 private colleges. So this is your X bar and this is your S. Your calculator calls this S of X, your standard deviation. So this standard deviation, note where it came from. It came from this sample of 25 private colleges. So when you read this, what you always have to look for is, all right, is my standard deviation from the population or is my standard deviation from a sample? So in this case, we could see that the standard deviation comes from a sample. So what this is going to do is this is going to push us to use a t-test versus the z-test. All right, so let's continue reading here. The dot plot shows, so imagine we have a dot plot, that it's reasonable to assume that the population is approximately normal. All right, so they're telling us it's approximately normal. Can you conclude that the mean tuition and fees for private institutions in California differs? So we want to see, based on what we see here, is there a difference? Can you conclude the mean tuition and fees for private institutions in California differs from $35,000? All right, we're going to use a level of significance of alpha is 0.01 here. All right. And we're going to use this critical method. So we have a p-value method and we have a critical method. We have this table here that you could feel free to use, but I'm going to show you how to use a calculator. It's just much easier. And in real life, right, you always use technology to do these types of problems, right? You have some cool technology that you're going to be working with. All right. So of course, they tell us that the dot plot shows us that the population comes from the population is approximately normal, right? So because of that, these assumptions here are met. All right. So then we have some options. If this is gonna be a left tail, right tail, or two tail. So notice if it says words like greater than, more than, we're gonna go with the right tail. Less than, right here, we're left tail. Not equal to, is there a difference? This right here. So notice in this problem, we want to see, does it differ? So that's why this is going to be a two-tailed test. All right. So when we set this up, notice H naught, right? H naught here is going to be mu equals 35,000. So we're saying, hey, it's not different from $35,000. That's going to be our null hypothesis, right? That the mean tuition is equal to $35,000. But what we're trying to prove is without a shadow of a doubt, boom, that there is a difference between $35,000, that the mean tuition differs from $35,000 based on what we got. All right. So using this critical value approach, the first thing we're going to do is we're going to find the critical value. Notice here, I found a plus and a minus, and that's because this is a two-tailed test. So when you look at the drawing, let's see, do they have a drawing? Later on, they're going to give us a drawing. This is going to be a two-tailed test. And our first job is to find these critical values because this is going to give us our cutoff region. And our shaded region here, if our test statistic falls inside of our shaded region, what that's going to tell us to do is to reject your null hypothesis. All right, so we'll get into that right now. All right, so we got a 210. What we're going to look for is these two values. So notice using the table, you can find these two values, but check it out. We're going to go ahead and use, so write this down, second vars, and then we're going to go to inverse t, which is number 4. Inverse t, it wants the area. So on inverse t, what I'm going to do is I'm going to punch in the area to the left. And notice this is a two-tailed test. So what I could do is I could put the 0.01, notice the 0.01, that's the total area. But because this is a two-tailed test, I'm going to divide it by 2. All right. Or I could put 0.005 because that's the area, let me show you, of each of these tails, right? That's this total area, the 0.01. So that means if I divide it by 2, that gives me the 0.005, which is the area of each tail, right? So when you have a two-tailed test and you're using this, then divide it by 2. If you don't have a two-tailed test, if it's just the left tail or right tail, then you don't have to divide by 2. Does that make sense? All right, I'll pretend you said yes. So the degrees of freedom, that's always n minus 1. So we had a sample size of 25 private schools, right? So our degrees of freedom is 25 minus 1, so 24. And then we hit paste. All right. And that's going to give us the negative 2.97, just like they have here. And the reason they're having a plus and a minus, again, this is a two-tailed test. What I did is I just entered the area to the left. All right. If I wanted to get the area to the right, then all I would do is I would punch in the middle area plus this tail, but that takes a lot more work. And so it just doesn't make sense. So remember, if you have a two-tailed test, it's symmetric. So that means you're going to have one that's negative and the other one's positive, right? So that's as easy as that. So these are your critical values, negative 2.797 and then positive 2.797. And again, because it's two tails and it's symmetric, right? We got 0 right smack in the middle. You get one that's positive and one that's negative. And we'll talk about this number right here. But remember, 0 is always smack in the middle. Okay. So now that we have our boundaries, as I call them, all right, you have your critical values. So next, we need to compute the test statistic because we want to see where does this test statistic lie for parts, step 3. Because if it lies somewhere in the middle, then we know, hey, we're not going to reject our null hypothesis. But if it falls somewhere in my shaded region, then we know we reject the null hypothesis. So depending where it falls. So this is our formula for test statistic. You could also use, go to stat, go over to test. If you go to ttest here, you could also plug everything in. Notice they don't give us the data. We have the stats, the statistics. So we can punch in everything. But again, this is the formula. So our mu is 35,000. That's what we're comparing it to. Our X bar, the samples mean, we got 35,500, 35,500. And then our standard deviation of the sample was 7,600. And then our N, our sample size is 25. And so what this is going to do is this is going to do all this work for us. And it's going to give us the 0.329 right here, the 0.329. So that provides us with our test statistic here. And it also provides us with our p-value that in some of these questions, they're going to want you to use the p-value approach. And for that, we're going to actually use this p-value. But right now, since we're using the critical value approach, we don't need that. All right, so we grab the 0.329. So this is what we have. All right, so now it's time for us to state a conclusion. If you're going to do this by hand, which I prefer you doing, but this is a cool calculator tool, so I don't mind. But if you do use a calculator, I want you to write out everything that you punched into your calculator. So I know that you're using it properly. So check this out. If I did this on the calculator, just make sure you use parentheses. Notice how I put in parentheses here. So 35,500 minus 3,500 or 35,000, excuse me. Close my parentheses, divided by parentheses. So everything down here has to go in parentheses too. So 7,600 divided by the square root of 25, which is just 5, but I'll still do second square root, just so you know how to do it. and then I'll get out of those. So that's how you get out of the square root. I just hit this arrow. If you have an older calculator, it's a little different. Close parentheses and hit enter. And so we get the same answer, right, that they did there. So again, regardless if you use the formula or use the t-test function in our calculator, you're going to get the same answer. So now what do we do with that? So let's label this. So notice what they did. Boom. We have it. Where is this on the map? So it's right here. So this red line here. So that's 0.39, 0.329 because 0 is right smack in the middle, right? So 0.329. Notice this line right here is not, this value did not fall in the shaded region. So because it did not fall in the shaded region, what we say is there's not enough evidence to, right? There's not enough evidence to conclude that the mean tuition and fees for private schools differs from 35,000. And the reason is, let me write this down. So you can write this down. So we did not, let me annotate on here. So notice it fell, this value fell, it didn't fall in the rejection region. So here what we say is you fail to reject, or you do not reject the H naught, but always tell me what you're not rejecting. So you fail to reject that. So you're not rejecting H naught. All right. So if we go back, I always want you to go back and remember what was H naught. So H naught right here said that there was no difference, right? That's what H naught is saying. So H naught is saying there is no difference. And so that's what we're saying. Hey, there is no difference in tuition, right? We didn't have strong enough evidence to conclude that. So there's not enough evidence to conclude that the mean tuition and fees for private schools differs from 35,000. All right, so that's using our critical value approach. Hopefully you see, okay, it's not bad, but you might have to watch it again because that's example one. Because again, it takes practice, right? It takes time. All right, let's take a look at the p-value approach. All right, so our p-value approach. So now you get your FICO score credit. Your FICO credit score is being used by banks and other lenders to determine whether someone has a good credit risk. So the scores range from 300 to 850 with a score of 720 or more, indicating the person is a very good credit risk. So economist wants to determine whether the mean FICO score is lower than the cutoff of 720. Right? So she finds a random sample. She finds that random sample of 55 people. So there's our N, had a mean FICO score. So there's our X bar because this came from that sample of 55. So this is our X bar with the standard deviation. So this is our S or our SX of 80 because this came from that sample as well. So can this economist conclude that the mean FICO score is less than 720? All right, and we're going to use a alpha level of 0.10. And this time we're going to use a p-value method. All right, so notice our mu is going to be 720. Our X bar is going to, because that's what we're comparing to, our X bar is going to be 685. Our standard deviation of the sample is 80. And we had a sample size of 55 people. And this is going to be a left tail, right? Because it says less than 720. Okay. So this is going to be a one tail. So what that means is when I plug this 0.10 to the calculator, I do not have to divide it by 2. Right? I only divide by 2 when I have a two-tail test. All right. So we set up the scene. The first one's equal to, right? We're assuming there's no difference. But then the economist is making the claim, hey, you know what? I think the difference is going to be less than, I think the actual average score is less than 720. All right. So let's go through this. So we go to stat, test, t-test, and let's plug everything in. All right, so this time, what do we have? Do we have data or stats? We have stats again. So our average, let me grab all this from our calculator, is 720, just to do it with you, right? Our X bar is 685. Our sample standard deviation, we said was 80. Our N was 55. And this time, make sure you choose this one where it's less than, right? Less than. And then we're going to hit calculate. So hit calculate. And this time, what we're going to be grabbing is this p-value. So remember, the lower the p-value, so notice our numbers come out exactly the same. So what I did is I put this on ChatGPT so you guys could kind of see. So when you get a p-value from the t-test, it's telling you whether the difference you're seeing between the two groups is probably real, or if it could have happened just by random chance. So if it's a really small p-value, right, you have something to worth looking forward. Tongue twister for me. You have something worth looking into further. So it got me on that one. So basically what it's saying is, man, look how small our p-value is. That's tiny. So what this is saying is you have really extremely strong evidence showing that, something is didn't happen by chance. Because look at the chance of us getting a mean of, what was our mean? What was our mean that we got earlier? It was 685. So the chance of that happening, right, is almost impossible. It's 0.1% chance. So there's something else going on. So our average FICO score is less than 720, and there's really strong evidence against that, are showing that it is less than 720. All right, so again, when you're trying to prove something, you want this p-value to be the lower the better. All right, so interpret the p-value. If making a decision, reject H naught. So because our p-value is less than alpha, so when your p-value is less than alpha, write that down. Let me write it down with you. Again, it's just like what we said when we had the z-test. So when your p-value is less than alpha, what that tells us to do is that tells us we can go ahead and reject H naught. All right, we reject H naught. So, and again, vice versa, if p-value was greater than alpha, then you do not reject H naught. All right, so here we are rejecting H naught. So let me go back and let's see, well, what is H naught? So we are rejecting this. So what we're saying is we have strong evidence to support this claim that the mean FICO score is lower than this cutoff of 720, right? So we're saying that we have enough evidence to get rid of this, and we conclude this. We have strong enough evidence to support the claim that the mean FICO score is lower than 720. So when we come over here, there's enough evidence to conclude that the mean FICO score is lower than 720. All right, so again, in this methodology, when we use the p-value approach, notice we did not come here and we did not use second vars. We did not use inverse t because it doesn't require you to find critical values. All right, in the other one, you did want to find critical values, but not here. All right, let me clear this and let's take a look at one more. Number 6, I wanted to look at number 6 because it gives us data. So just note that because when it provides us with data, we still have to go through the run through. It's going to give you a box plot, and we can see it's approximately normal here, right? Our box plot, and there's going to be the conditions that you have to make sure are met. So make sure your sample size is a simple random sample. make sure the sample size is greater than 30. If not, then it can't be skewed. It has to be approximately normal. So again, it's greater than 30, or if it's not greater than 30, the population is approximately normal. So here we could see by this box plot, we have something that's approximately normal. So let's see what we're trying to do here. In an attempt to increase business on Monday nights, a restaurant offers a free dessert with every dinner order. Call and order now. This reminds me, this video is sponsored by the Cheesecake Factory. I wish. Before the offer, the mean number of diner customers on Monday was 150. Following are the number of diners from a simple random of 12 days while the offer was in effect. So these are the number of diner customers, right, on those Mondays. And so they went ahead to the box plot. This is what they got. Cool. So what we're going to do is, let's look at the question here. So can you conclude that the mean number of diners decreased while the free dessert offer was in effect? This time we're going to use the alpha level 0.01. So you could see right away. And what do they want us to do? They want us to use a critical value method. All right. So we see that those conditions were met because we wanted to see if there's a decrease in customers. That's why your alternate hypothesis was mu is less than 150. All right, so less than 150. And then of course our null hypothesis says there's no change. The average is still a 150 while this dessert offer was in effect. All right, so let's go through and let's use inverse T because we are using the critical value approach here. So I do not need to divide by 2. 0.01 is my area. I don't divide by 2 because it's just one tail. My degrees of freedom here, there was the sample size of 12. So my degrees of freedom is 11. It's always one less. And so we get our critical value of negative 2.718, 2.718, just like they got. They use the table. I'm just using the calculator, so you don't have to worry about the table, okay? So if you want to do this by hand, using the test statistic formula, then you're going to actually have to go through and you're going to have your calculator spit out the mean and standard deviation. This is great, this is fine, but it's much easier to let your calculator do the heavy lifting. So what I'm going to do, just to show you, right, is I'm going to go to stat, I'll go to edit, and I'm going to put these numbers in a list. So I'll just put an L1 here. It doesn't matter which list. So let me type these in. And you just take a look, make sure I don't make a mistake. Did you say steak? Let's see. Let's see if this works. This shouldn't matter. Yeah. 44. You saw that mistake, didn't you? I was just making sure on your totals. This one should have been. And let's see, to correct a mistake, you just type over it and hit enter. All right, you don't even need whiteout or nothing. So I have all my values in L1. So now I could go to stat, test, ttest. This time I use data. So I'll go over, hit data. My mean, my mu, we're comparing it to 150. Everything's in L1, frequency 1. We're doing less than, oops, it was already high, less than. Then we hit calculate. Boom. And so this that they did by hand, which is fine, right? They just, that's nice. But again, I get the same answer right here when I do it using t-test. So you could either use the formula or you could just use t-test, and it's up to you. And so we're going to compare that. So notice the first step we did was we found our critical value. So when I draw my curve and I have a left tail, this is my boundary line, right? My cutoff score. So this is my shaded region, right? My tail is my shaded region. So now I want to see where does this value, my test statistic, fall? Right? Does it fall inside the shaded region or does it fall outside? So here we could clearly see it falls outside of the shaded region. So when it falls outside of this shaded region, what we conclude is we do not reject H naught. So again, when our value or test statistic falls outside of the shaded region, we do not reject H naught. So that's what we conclude here. So because we do not reject H naught, let's see what did H naught say? H naught says that there was no difference, right? So we don't have enough evidence to conclude that the average amount of customers decreased. So there is not enough evidence to conclude that the mean number of diners increased while the free dessert offer was in effect. But let's just think about this, right? This is kind of a dumb problem in my opinion, because you would want to see what if you offered free dessert. You would want to actually check to see if there was an increase in diners while you offer this, because if it's working, then you keep with this promotion, all right? Or you're doing something right. And so, but again, it's just mainly to get us used to these types of problems. But again, you can see hopefully the usefulness of these types of strategies. All right, mathletes, I hope this is helpful. Hope you're having a wonderful day. Make sure you comment, like, subscribe, and I'll see you guys in the next video. Peace.